I'm Alex Soroyan, CEO and co-founder of Netris. We're a software company focusing on network automation, abstraction, and multi-tenancy for AI and cloud operators. And this section is focused on how we do this, how we automate and deliver multi-tenancy for cloud providers, for AI and cloud providers. So just to remind you, just to set context, we had this notion of 3 pillars, which is basically an ability for infrastructure operator to have the notion of VPC, like in the cloud, to have the notion of cloud networking functions, basically functions that switches do not do, but are required in the network, and fabric manager functions, functions for managing, operating the fabric for day-to-day operations. Now, how it works is this. It starts with Netris Controller. Controller is a centralized place where, this is centralized place, first of all, for network engineers. On day 0, on day 1, network engineers need to set this thing up, right? So, back in the day, network engineers were using a lot of, Visio and like Excel sheets to kind of, work with some data and do some preparation, which is perfectly fine. Here we provide some tools which help network engineers to do some of this preparation right inside the controller. So you're not only drawing a diagram, but your diagram is becoming kind of set of objects talking to each other, basically helping network engineers to define the source of truth for the network. Very helpful with day 0, day 1 operations for network engineers. Then they plug the hardware. They bind physical hardware with logical objects in the controller. We understand that. We install the operating system, then we install a lightweight agent on the switches. That way, agent talks to controller, and there's a number of algorithms in this agent that these algorithms are, translating these high-level intentions into actual validated configurations, and that way, network works. Now, on day 2, we also provide APIs to cloud providers, which are not that are not necessarily for network engineers, but are more for compute and storage for other guys. So as a cloud provider, you are connecting all this compute, storage, and networking together. You need APIs to make your different platforms talk to each other. And especially when you are building your user-facing portal, you need APIs to call on the backend. So for example, when a tenant comes in, you want to create tenant in the system. And we'll see these examples in the coming slides in more details. Question?
I have 2 questions. One, about the day 0, 1, do you have a kind of infrastructure as code capabilities to deliver when the switches are connected?
Yeah, that's a great question. So we do our controller, and you will see this a little bit in the demo, but in short, controller has 3 interfaces. They are equal: web, REST API, and Terraform.
Oh.
So if you as administrator of that AI cluster, if you want to treat your network infrastructure through infrastructure as a code methodologies, you can talk to Netris Controller in Terraform.
Okay, and another question is for a platform engineer's perspective. About monitoring and telemetry, do you support any open telemetry or stuff like that?
Yeah, good question too. So we collect telemetry from the switches and send telemetry to our controller using our proprietary tech methods.
Okay.
But that way, you have all this data in our controller, and some customers, they like to have like all this data in Grafana or somewhere centralized. This data is collected through proprietary method into controller, but in the controller, it's available to you. So you can take all this data from the controller, and you can view in your Grafana or whatever you're using.
No integration with Grafana and. Gotcha.
It's not our integration; it's community integration. Community is doing this, and this is all possible.
Gotcha. Thank you.
Do you have Ansible integration as well, or do you have it planned?
No. We don't have Ansible integration, but we have REST API, which can be consumed in that format.
And how do you get access to the APIs? Can you just go to your landing page and get to it from there?
So API documentation is built into the product. During the demo, I will show a little bit. Yeah. But it's if it's a new customer and they don't have access to API, there are ways to help customers to read to familiarize with the API like upfront when they are doing evaluation of the product.
Okay.
No, nothing to hide from that perspective. Okay, and component number 2 is what we call SoftGate. Now, switch management and isolation, all that is very important, obviously, but there are some functionalities that switches cannot do, like elastic load balancers, like network address translation, like elastic IPs, and some others. Now, these functions are critically important, and one way to have these functions is to involve other products like dedicated firewalls or dedicated routers, which is fine. That's okay, and that is compatible with Netris. There's no conflicts. But we offer this additional alternative option where we have this component called SoftGate. It's a gateway that's running on Linux servers. It is optimized, it is horizontally scalable, it is aware of tenants. So you can have millions of tenants, millions of VPCs, and this thing is designed to scale like that. And the great thing is that when you use external router or firewall, you're gonna have the challenge of connecting, making APIs of 2 different platforms talk to each other. APIs of your switch fabric to talk to APIs of your firewall. That's a tough task for a cloud provider. In case of SoftGate, all that is done. It is 100% integrated in Netris. It works seamlessly, and I will show this in the demo. Now, just an example of what typical network looks like, and kind of to walk you through the process from going from like day 0 to like having running cluster. Typical AI cluster has 2 networks, front-end and back-end network. Our controller talks to these different switches through out-of-band management, which is typically not Netris managed. It's kind of separate network for safety that we leverage to make these agents running on every switch to talk to our controller. Same management network is also used for our SoftGate nodes to talk to our controller. And we also optionally manage the host networking. Not every user needs this, but some need this. And in that format, we also run an agent inside the host, and that agent communicates with the network, actually using LLDP and some smart algorithms over LLDP to learn different things about such as like IP addresses, routes, and program some IPs and routes that is especially useful for backend network in AI fabrics. And that agent also configures SuperNIC, that also configures DPU. And in the future releases, we will also support granular multi-tenancy through terminating VXLANs, VRFs, and other constructs directly on the DPU inside the server. Now, Netris Controller is typically used by network engineers as well as other platforms. So if cloud provider has this end-user facing user interface, oftentimes we are kind of backend for network functions of that. Or some customers are using different PaaS platforms. Again, we have integrations with different PaaS partner platforms where they again use our APIs to basically provision networking, to create VPCs, networking functions, etc. If backend network is based on InfiniBand, in that case, we don't touch InfiniBand switches directly. InfiniBand world has this amazing fabric manager called NVIDIA UFM. So instead, we instead of like loading agent on the switch, we tie our agent to UFM fabric manager. This way, Ethernet customers and InfiniBand customers, they get exactly the same experience. Same APIs, absolutely zero difference. Now, on day 0, day 1, what happens? First step in the data center. In data center, first comes network. You need network to be there to be able to install compute and storage, etc. And how do we bring that network up? So Netris Controller comes first because it is source of truth. And then typically either implementation team tells, kind of models what network is going to be in Netris Controller. Implementation team can be customers team, can be our professional services, can be system integrators professional services, or vendors professional services. We work with all of them. Now we provide tools that help to through Terraform and using DevOps methodologies, help them to describe their infrastructure in Netris Controller. So through Terraform, you can say, hey, I'm building leaf-spine fabric, or I'm building AI infrastructure based on NVIDIA Spectrum-X architecture. Now, we know what is Spectrum-X architecture and NVIDIA's RA for that. And in that case, we would say, hey, how many nodes do you need? How many uplinks do you need? We will ask very basic questions, and we would help you to populate the controller. Then you can make some simple changes. Once you have, told controller what you're building, you can simulate that. So, there's NVIDIA Air, which is simulation platform, which we are compatible. We can simulate, we can create a digital twin in NVIDIA Air. But we also have our own platform. We call it CloudSim, which is actively used by our developers, our customers, evaluating customers, our partners who are integrating with us. It is incredibly easy way to like experiment and build and evaluate infrastructures. Once it's done, evaluated, hardware is there, switches are wired, and we detect switches, we identify them by MAC addresses, and we install operating system, our agent run configuration, they are up, and your network is kind of in a ready state. You can start onboarding your tenants. Now let's say you get 2 customers, 2 tenants, let's say Coke and Pepsi. So they knock your door, hey, I need 5 servers, I need 25 servers, whatever. You describe that very same thing in Netris Controller. Servers 1, 2, 3, 5 go to tenant 1. Servers 20, 25, 23, whatever, go to tenant 2. Enter. And because Netris is source of truth, it knows all your topology. It knows how your servers are wired, connected, how your network is dealing. Netris knows, is this NVIDIA network? Is this Arista network? Is this InfiniBand? What are the best practices? So these algorithms automatically go and generate appropriate configurations on every switch. If it's a bare metal, the isolation would happen on the switch ports, basically on the switch layer. If it's, after that, provisioning is done, VRFs, VLANs, VXLANs are create it, and your servers can talk to each other. Now, there's always this question of granular multi-tenancy, like how to do this per GPU, per container, per VM levels. This is done through extending VXLANs to the host. So basically, either making the entire server participant of the VXLAN fabric, or making the DPU participant of the VXLAN fabric. So meaning the same protocols that switches talk to each other, they also talk to switches, treat your servers as if servers were switches too. Kind of like that, using EVPN, BGP, EVPN signaling methods for VXLAN. Then very, very common question. You have these two tenants, Coke and Pepsi, for example. And how do we provide shared storage? Now, different storage vendors, they have different methods to identify customers and to isolate. But typically they support either of two methods. One is to have different VLANs for different tenants, and one is through what is called VRF leaking, or we call it VPC peering. Now, how AI infrastructure cloud provider can implement this? It is easy for a storage provider to say, "Oh, just configure VRF leaking and it will work." Of course, that's storage provider's requirement, but it is challenging for AI infrastructure operator to configure that peering dynamically on the fly without making, when you're implementing configuration for one tenant, you cannot break operation of other tenants. They're using workloads. It's a production. So it's a cloud experience, right? Your customers don't expect things to stop working just because you are onboarding another customer. So again, because we have this notion of VPCs, we have this notion of VPC peering, just like in typical cloud, where from cloud provider's perspective, it's a simple object that says, peer this VPC with that VPC. In this case, you want to say, peer my tenant Coke with my tenant shared storage, and peer my tenant Pepsi with my VPC shared storage. That way, Pepsi and Coke cannot talk to each other. They can talk to storage, but they cannot talk to each other, because storage would have its own VPC, its own VRF. It is not transiting any traffic. And the configuration on the network, and this is AI network, hundreds of switches. Configuration on the network is kind of like that. You see that, green lines. It's basically hundreds of green lines like that on every switch. It's not, you cannot copy and paste if every switch has its own configuration. But it's the algorithm that knows how to properly organize the VPC peering, VRF peering, and it's from cloud provider's perspective, it's not their problem anymore. It is our algorithm's problem, which is obviously rigorously tested in virtualized and physical environments, and it's also being run by lots of customers.
Right. Quick question. Brian Martin, Signal 65. When you're looking at VPC storage and storage VRF functions, you have a qualified set of storage vendors you work with that you interact with so you can configure them, or how are you managing that interface?
Yeah, there's so we're intending to work with everyone. There are some storage vendors with whom we work closely. When time comes, the announcements will follow, but we work closely, and the idea there is for them to integrate with our API, and them, by seeing different parameters in our API, they can kind of automatically understand who to permit access. Now, let's say particular AI customer is using storage vendor that we don't have integration. We are seeing all the storage vendors in different deals, and we don't have kind of API integrations with all of them. With some of them, it's in progress. But even if there is no integration, this solution is already sufficient. Because what we do, we provide the access from networking perspective, right? From storage vendors perspective, it is one network. The network of storage is still living inside the same switch that we manage, right? So we basically manage access to that network. We say tenant Coke can access storage, and storage vendor itself, they know that tenant Coke has these IPs, and if traffic comes from tenant Coke, or if traffic comes from these IPs, I should serve, because I trust that traffic is really coming from that tenant, because Netris is enforcing this in the VRF leaking layer.
And in the case of the storage, they know that that IP address is acceptable because that was configured a priori, eventually through your API?
Yeah.
Okay.
Yeah, they trust that VRF leaking is configured appropriately. In the future, we will do some integrations with some storage providers where they will not even need to know the IP of the tenant. They will see it.
But I assume you're just using agents that you put together to deal with the storage APIs.
With storage in today's situation, agent is not required. There's no need for integration.
You have a direct integration with the storage vendors you work with now?
Today, we just control network access, and network is still managed by Netris. See, storage vendor is basically that, right? Storage servers are connected to North-South fabric, and North-South fabric is entirely managed by Netris. Now, the way AI infrastructure operator configures the system, they give us the notion that these switch ports are not connected to tenants, but are connected to storage. So, and then because we know that this is storage, this is not random server, we're able to, when they say, provide VPC peering, means we actually, in this slide, when provider says Coke, tenant Coke should access storage, we understand, okay, we will go and configure all the appropriate rules in the switches. So traffic which is exiting server from Coke, trying to travel to storage, will not be blocked.
Okay, but do you have any provision for handling multi-tenant storage?
Storage should be provisioned separately. Storage should know that there's Coke and Pepsi tenants. Storage should expect this traffic. Yeah.
But it would be potentially over the same network connection that you would access it.
That's a good point. So today, AI infrastructure provider needs to tell Netris about tenancy and storage provider.
Okay.
Two separate calls. Possibly in the future, and we work with some storage providers on this, there will be integration where AI infrastructure operator will tell us about tenancy, and storage could pick up that information from us.
Okay.
Question: It seems like you're trying to build that abstraction that would make us. If I had to go build all of the declarative Terraform myself to do this at scale, right?
Mm-hmm.
I'm talking multiple TF files, and I have to then ingest all of the vendors. Are you still building a declarative approach out to all of the networking infrastructure? So you have templates, you have code that can be defined as it goes to each vendor? What's kind of the layer between Netris Controller and the switch? Is that something that can be modified or looked at?
That can be. You mean by customer, like how much can customer extend?
Yeah,
That
by customer or by use case.
Yeah.
All of the above.
So we today we provide most essential abstractions. In terms of vendor support, we support these 4 vendors: NVIDIA, Arista, Dell, EdgeCore. For us, this is individual development for every platform, right? Every platform has different commands, different best practices. Something is possible, something is not possible, and you need workarounds. So our algorithm needs to take care of all that minor details. Now, we develop our roadmap based on basically demand and customer needs. It is very much focused on AI and cloud infrastructure use cases. Most of our customers are either running AI or they are cloud provider. So for these 2 use cases, we have really good coverage. Now, if someone wants to do like something else, we should talk. Sometimes we would say, hey, customer, what you are trying to do, we have the building blocks. Maybe you can leverage these APIs. Here's example code. You can do a little bit of your own additional development, and you can extend to your use case. Okay, that was storage. And another very common question is, okay, we figured out storage sharing, and the other question is shared network services. So how do I provide internet access to my tenants? How do I, if I have like a data scientist that's trying to access this cluster from the outside, how do I give them elastic IP? And of course, it's possible to do with like dedicated firewalls, routers, but the level of integration you need to do, you as a AI cloud provider, you need to invest so much efforts into this automation between firewalls, interface, and your fabric managers API. We have this alternative option we call SoftGate. Through SoftGate, we are able to provide this kind of same simple abstraction where you can say, hey, Netris, let's create a NAT rule. Or, hey, Netris, let's create an elastic load balancer. And how it works is following. See, in a switch fabric, in a modern switch fabric, switches talk to each other through EVPN, BGP, and that way they run VXLAN tunnels, and that makes the switch fabrics very flexible and scalable. Now, the SoftGate nodes are basically Linux machines running Netris with some acceleration, with some smart algorithms that we've created to do some things right and scalable. Now, SoftGate nodes, they talk to the fabric using same BGP and EVPN and VXLAN methods. So to switch fabric, SoftGate is like another switch. But in reality, SoftGate is not a switch, it's a server. It can do different things that switches cannot do. And that way, SoftGate, if Netris wants, SoftGate can access any VXLAN, any VPC, any tenant, basically. So when customer says, let's provide load balancing service for SoftGate, first of all, how SoftGate gets connected to the internet itself. Typically you have your border switches and they have links connected to upstream router or upstream internet provider. Now SoftGate forms a BGP sessions with these upstream providers, which is kind of very easy for network engineers to figure out how to organize this. That way, SoftGate has access to the internet. SoftGate can terminate some public IPs. And when a cloud provider or their customer is requesting for elastic IP or elastic load balancer, SoftGate can pick an IP from its pool, and that IP is visible on the internet. And the traffic coming on that IP can be serviced by SoftGate and load balanced further towards one of the tenants. or NAT, network address translation. So that's the principle how SoftGate works, and I will show this a little bit soon in the demo. So oftentimes, when we show the product to engineers, they say, "Hey, common questions like how do we're evaluating this for our use case. What are the important things? What are the important angles we should keep in mind when we're doing this evaluation? How you compare to typical hardware to products coming from typical hardware vendors. There was a question, Arista, Cloud Vision, right? Very common question. Or like other offerings, right? Other independent network software vendors. Some of the important differentiators are we're multi-vendor. We don't manufacture hardware. We don't care what hardware you use. We want you to be successful. We provide these cloud networking constructs, which is, typically traditional network automation platforms. They were designed more for enterprise data center use case, and they don't necessarily optimize for this kind of AI cloud builder kind of use case. We have this SoftGate, which is kind of unique in terms of we haven't seen similar product elsewhere. Typical approach is to have a firewall, to have a separate load balancer, which is okay. We support that use case, absolutely no problem. But for a lot of customers, and a lot of customers are saying, can we use Netris without SoftGate? We're saying, sure. You'll be surprised to know that we probably have only like 1 or 2 customers that are not using SoftGate. They all use it. They all love it because they're like, this is cool. Like, well, it works fast and it's all integrated. We support both Ethernet and InfiniBand. Yes, it's a simple plugin through NVIDIA UFM integration. It's not much, and we charge very small amount for that small integration, but it makes customers' lives so much easier. And we are verified NVIDIA Spectrum X solution.
Question, Brian Martin again. Other ISVs, when you look at the market and what you're offering, who would you say are your top handful of competitors in this space?
I think that's an interesting question. Not typical hardware vendors. In a regular CPU cloud, I would say typical hardware vendors like Arista, Cloud Vision, like Cisco ACI. In AI, not them, but the main competitor, in my opinion, is doing it yourself, like building kind of artisanal automation in-house. We see them as a main competitor.
Okay, so you feel like you're the leader in this space, bringing a solution to companies who've been trying to do it themselves.
We were lucky to be building something starting from 2018. 2018, people were asking me, Alex, what is it that Netris is building? I was saying software for cloud providers, and people were like, cloud providers like Amazon? I was, no, others. And people, who are these others? Right, in 2018. Like 3 years ago, there were some. And people were saying, how is it going? I was saying, it's not bad. We were getting some customers. We're still alive. We can survive this way. But today is a different situation. Today, every AI infrastructure operator is basically cloud provider. So I think we've got lucky to be in the right time, in the right place. I know a lot of other companies are building solutions in the space. There are competitive solutions, of course. Some of them are decent. I don't know, everything about all of them, but obviously the market will catch up, right? It's a huge market, but it's a big enough. There's room for everyone. Are we a leader? I think we have the opportunity to become one. We're hoping to be one.